Need to expose dynamic data endpoints, where each request can generate tailored responses while maintaining clean separation between URI routing and implementation. We'll build 2 FastMCP resource endpoints that demonstrate the framework's URI pattern system. A system status endpoint that automatically includes request metadata, and a parameterized details endpoint that creates custom responses for any input name. You'll see how URI placeholders like name map directly to function parameters, while the context object provides essential request tracking through requested and optional cliented, with all responses automatically serialized to JSON. The decorator handles the routing and content negotiation, letting you focus on the data logic. From FastMCP, import FastMCP. Context. MCP equals FastMCP. Name equals data server. At MCP resource system status. Async def get system status CTX. Context. Dict. Provides system status information. Return. Status operational. Requested CTX request ID. At MCP resource //name /details. Async def get details name. SDR CTX context. Dict. Get details for a specific name. Return. Name. Access stat CTX request ID. This demonstrates FastMCP's resource URI pattern, a declarative approach for exposing data endpoints through URI templates. The pattern enables both static endpoints like system status checks and dynamic parameterized resources like name-specific lookups, all through a unified, at MCP, resource decorator interface. The key distinction is that these resources are specifically designed for read-only data access via the resources read operation, with URI path segments automatically mapped to function parameters. The system works by treating decorated functions as resource handlers, where the URI structure defines the access pattern and parameter extraction. When clients request resources, FastMCP matches the URI, extracts path parameters, and invokes the corresponding function with those values, plus an optional context object containing request metadata. The context provides async logging methods like await CTX, info, request identifiers including requested and potentially cliented, which may be none, and transport-specific identifiers like sessioned, HTTP only. Resource metadata including name, description, and MIME type can be configured through decorator arguments, with defaults pulled from the function name and docstring. This pattern eliminates boilerplate for exposing structured data while maintaining clean separation between interface definition and implementation. It's particularly valuable for configuration systems, status monitoring, or any scenario requiring both static and dynamic data access. The trade-off is that complex parameter validation becomes the function's responsibility. But the benefit is a maintainable system where resources can be versioned, tagged, and exposed with consistent metadata handling while keeping core logic focused on data generation. Let's break it down line by line. From FastMCP, import FastMCP. Context. This imports FastMCP, the core class for defining resource endpoints, and context, which provides request metadata including requested, optional cliented, and HTTP-only sessioned. The context object serves as the main interface for request handling, offering async logging methods like await CTX, info, and access to version-specific features like request context meta in FastMCP 2.13.1+. These imports establish the foundation for creating both static and parameterized resource endpoints with explicit metadata control through decorator arguments. MCP equals FastMCP. Name equals data server. Initializes the FastMCP server instance named data server as the central request router. This instance manages all resource endpoints, handles connection pooling, and serves as the foundation for both static and parameterized URI paths. The name parameter identifies the server in logs, metrics, and service registration, while enabling proper request isolation between multiple MCP instances. At MCP resource/system status. Async def get system status CTX context dict provides system status information. The @MCP resource decorator exposes this async function as a FastMCP resource endpoint at resource/system status, specifically for read operations. The context parameter provides request metadata including requested, optional cliented, and HTTP-only sessioned, with async logging methods like awaitCTX info, available for version-specific tracking. This pattern separates URI declaration from implementation, while defaulting resource names to function names and descriptions to docstrings. Return. This returns a dictionary that FastMCP automatically serializes to JSON for the client. The @MCP resource decorator registers this as a read-only endpoint under the resources/namespace, with the URI pattern mapping path segments like name directly to function parameters. The context object provides request metadata including requested, always available, cliented, maybe none, and sessioned, HTTP transports only, plus async logging methods like awaitCTX info. Resource metadata defaults to the function name and docstring, but can be explicitly configured with versioning, tags, and MIME types through decorator arguments. Status operational. This hard-coded status value serves as a minimal health check response, confirming the service is operational. The fixed operational string provides clients with immediate availability verification while demonstrating FastMCP's automatic JSON serialization of return dictionaries. This pattern shows how resource endpoints can return both static and dynamically generated data through the same interface. Requested CTX request ID. This injects the unique request identifier from FastMCP's context object, which provides requested as a mandatory field while cliented may be none if unspecified. The sessioned is HTTP transport specific and unavailable for other protocols. The context object serves as the primary interface for request metadata and capabilities, with async logging methods like awaitCTX info and version-specific features such as request context meta in FastMCP 2.13.1+. Resource URIs declared via @MCP resource follow the resource's read operation pattern, supporting both static paths and dynamic segments like name that map directly to function parameters. This closing brace finalizes the dictionary that FastMCP automatically serializes to JSON for the API response. The @MCP resource decorator registers these functions as addressable endpoints under the resource's read operation, with URI templates like name becoming direct function parameters. The context object provides request metadata including requested, optional cliented, maybe none, and HTTP-only sessioned, along with async logging methods like awaitCTX info. Resource metadata defaults to the function name and docstring, with optional overrides for versioning, tags, and MIME types, primarily for non-text responses. This pattern creates clean separation between URI declaration and implementation, while supporting both static and parameterized paths. At MCP resource/name/details. Async def get details name, SDR/CTX context, dict. Get details for a specific name. This defines a dynamic resource endpoint using FastMCP's URI template pattern. where name in the path automatically binds to the function parameter. The @MCP resource decorator exposes this as a read-only resource operation, accessible via the resource's /namespace, with the URI template enabling parameterized paths while maintaining type safety through Python's function signature. The context parameter provides request metadata including requested, always available, plus optional cliented, maybe none, and sessioned, HTTP transport only, alongside async logging methods like awaitCTX, info. This pattern cleanly separates URI declaration from implementation while defaulting resource metadata to the function's name and docstring. Return. This begins constructing the dictionary response that FastMCP automatically serializes to JSON for all resource endpoints. The context object provides requested as a unique identifier, cliented, which may be none if not initialized, and sessioned available only for HTTP transports, while requiring await for its async logging methods like awaitCTX, info. The standardized response format ensures consistent API behavior whether serving static paths like resource, //system status, or dynamic URIs with parameters like resource, //name/details. Name. This extracts the dynamic name segment from the resource URI pattern and injects it as a function parameter. FastMCP's decorator automatically parses URI templates into clean function arguments, eliminating manual string parsing. The resource URI pattern specifically targets resources read operations, with the shown example using the minimal required URI parameter. Context provides request tracing via requested, while cliented may be none and sessioned exists only for HTTP transports. Access.ctx request ID uses CTX request ID to embed the unique request identifier in the response, enabling end-to-end request tracing. The context object provides core request metadata including requested, always available, cliented, maybe none if unspecified, and HTTP only sessioned, with all properties accessible via CTX, request context. This follows FastMCP's standard pattern where resources receive context for metadata access and execution tracking. This closing brace completes the dictionary that FastMCP automatically serializes to JSON for the response payload. The @MCP resource decorator exposes functions as addressable endpoints following the resource's read operation pattern, where URI templates like name map directly to function parameters, while the context object provides request metadata including requested, optional cliented, and HTTP-only sessioned for traceability. All resource endpoints support explicit versioning, tagging, and MIME type configuration through decorator arguments, though the example shows the minimal form with just the required URI parameter specified. Resource URI pattern. The @MCP resource decorator transforms Python functions into addressable endpoints where URI templates like name become direct function parameters, creating a seamless bridge between HTTP paths and Python logic while maintaining static type safety. Cliented may be none if not provided during initialization, and sessioned only exists for HTTP transports. This pattern enables both fixed endpoints like system status and dynamic ones like name-specific details through identical decorator syntax, with all metadata automatically derived from function names and docstrings unless explicitly overridden.
The endpoint that answers every request was never given an address.